Assalamu alaikum. Welcome to another Telekilaas on mathematics. Today I am going to teach you the topic of integration which appears in P1 A-level mathematics. The outcomes of this lesson would be the following. After completing this lesson, students should be able to understand the meaning of indefinite integration. Also, students should be able to integrate simple functions. And as the last one, students should be able to find the constant of integration. But to understand the topic of integration, we need to know few other skills which are required to do the integrations. One of them is the laws of indices. You should know the laws of indices very well. Especially, there are two very important laws that you should know. One is the law of radicals here. We have a square, we have a root here, converting the root to a power function. And also, students should know how to convert this kind of functions to power functions of this form, which we call rational form converted into exponent form. So, let us do some examples on them. Here we have a radical, in other words we have a root. We need to convert this to the power form. So, to be able to do it, we will apply the law. So, we apply the law like this way. We need to know that these two numbers, as we have seen from the law, that we have to have a fractional power there. So, to be able to get that fractional power, we apply the law, and applying the law we get 2 over 3. Be very careful about this. This power, the power is on the numerator of this fractional power, and the root goes to the denominator of that rational power. It goes like this way. 2 goes to the numerator and 3, which is the root, goes to the denominator. This rule will be very, very important in integration. Second example, here we have a square root of x. Now, as we can see, again we have a root, and also you can see that there is no number written here, because that symbol is reserved for square roots, and the power of this x is also not written, it is 1. So, when the power is 1, we do not write. And if we convert this to power form, we can see that two numbers will come here as the power, which is a rational power, a fractional power. And as before, when we apply the law, the power which is here goes to the numerator, and the square root sign, which is 2, goes to the denominator, having x to the power half. As you can see, the power of x goes to numerator and the square root will go to the denominator. Hence, we have x written, in other words, this expression is written in root form, or in power form. If we have an expression like this, we have 1 over x cube. To write this one in exponent form, we should take this x cube up, and the rule is that a power will come here, and that power will be the opposite side of the power in the denominator, which will be x to the power minus 3. As you can see, it is that 3 becoming a negative 3, and then we get the fractional expression, but now in terms of an exponent form. So, we get x to the power minus 3. We have this expression here in number 4, example number 4. So, 5 over x to the power minus 4. So, we need to write this expression in power form or exponent form, and we get an expression like this, where we need to write a number, and that number will be a minus 4. But remember that this is already a minus 4. So, that will become a plus 4. As you can see, 5x to the power minus 4, it becomes 5x to the power 4. So, knowing these two rules together with other laws of indices will be very, very important in integration, because when you do integration of functions, some compound functions, complicated functions, you will have to make the expression ready for integration. When you make the expression ready, it is often that we use laws of indices, especially the two rules that I have discussed here will be very, very important. The other skills required to do integration is the process of differentiation. One of the teleclass already done on differentiation. From that class, you may have seen how the process of differentiation is carried on, and we have seen some questions also done on them. But to start integration, we need to recall differentiation as well. So, if you go through differentiation, you all can know that the process of differentiation takes a function and produces a derivative function. So, the derivative function is normally written as dy by dx, which is a rate of change, dy by dx. And the formula for differentiation is this rule here. We multiply the power and the exponent and then reduce the exponent by 1. So, that rule you have seen, multiply the exponent by the coefficient and then reduce the exponent by 1. This process will be important for integration, because integration is going to be the reverse process of differentiation. So, it will be easy for us to reverse it. So, again to reiterate, differentiation takes up a function, then within the process it differentiates the function, produces a product called dy by dx. So, takes up a function, do the process, get dy by dx as the product. So, what is the integration? Integration and differentiation both come under the very famous mathematical field called calculus. Calculus is one of the most important topic in modern mathematics. So, in A-level syllabus, we do have a very brief introduction to both of these areas. So, calculus and calculus with integration and differentiation forms up a very big topic in A-level syllabus. So, as I told you before, calculus has two branches, differential calculus and integral calculus. Today, I am going to talk about the integral branch of calculus. So, it is one of the branches of calculus, and it is the reverse process of differentiation. The easiest way to understand integration is to know that it is the reverse process of differentiation. So, since you have learned how to differentiate functions, learning integration will be very easy if you understand differentiation. So, let us recall again differentiation. It takes up a function, do the process of differentiation, produces dy by dx. So, if you reverse this, what do you get? If you reverse this process, you will be therefore starting with a derivative function. Sometimes the derivative function is also called gradient function. Okay? So, if you start with the derivative function, then does some process, produces y, then that process will be called integration. So, integration takes up a derivative function, which is the reverse of this one, and does some process, that processing is called integration, and produces a product. This time the product is the original function. So, it has reversed the process of differentiation. So, let us take an example. Suppose I have a function, that function is y is equal to 3x squared. Now, I want to apply differentiation for this simple function. So, differentiation means multiply the exponent by the coefficient exponent is this one, the power by the coefficient, and then reduce the exponent by 1. So, if you do so, you will get 3 times 2 will be 6, because you are multiplying the coefficient by the power, which is 6, and then reducing the power by 1. So, 2 becomes now 1, because if you subtract 1 from 2, you get 1. So, 6x to the power 1, that one we never write in algebra. So, we get the expression dy by dx equal to 6x. Let us take another example. I am taking this time y is equal to 3x squared plus 4, very similar to this function, but an extra constant has been added. So, what happens? If you differentiate this function, you still get 6x, but the constant gives you 0, as you have seen in the previous lesson on differentiation. You know that if you differentiate a constant, you are going to get 0, because a constant never changes when other variables change. So, dy by dx is equal to 6x. If you take another example with the same expression, but this time subtracting 300, you still get 6x. So, there is some kind of relation in here, is in that 300 added or 4 or any number, in reality if you add, it does not change the derivative function. So, if you reverse this, what is going to happen? Let us take another example here. So, this time we take y is equal to 3x squared plus a constant. Remember, I have been writing their numbers. Now, I am writing a constant c, which is an undetermined number. So, any number, really, it could be any real number. So, we still get 6x. So, now let us ask this question. How do we find the function y when derivative is given? If this 6x is given as a derivative, how do you go back? And that process is known as integration, and that process also has another name called indefinite integration. We call it indefinite integration because we will have a constant value here, which is an undetermined constant, and that will be named as the constant of integration. So, the answer to this question is definitely do the integration, because we know the derivative function can be, the original function can be derived from the derivative function by applying integration. So, it is time now to learn how to integrate functions. So, let us take an example again. I am writing lots of time differentiations here. Differentiation takes a function, multiply the coefficient by the power, reduce the power by 1, and then we get the derivative. If you do integrate, you start from here. You have a derivative function. First step is to increase the power by 1. Why? Here we reduce the power by 1. Now we increase the power by 1. So, if you increase the power by 1, you add 1. Okay? And then here we multiply the coefficient by the power, but there we divide the coefficient by the new power. Why are we saying new power? It is because the old power, if it is 3, if you add 1, it becomes 4. So, the new power will be 4. So, divide, here multiply, there divide. Coefficient by the power, coefficient by the new power. So, it is very easy to understand integration, just reverse differentiation, that is all. And then you get the function. So, again let us summarize it again. The integration takes up a derivative function, and when you try to integrate, you have to increase the power by 1 and then divide the coefficient by the new power that you have obtained, and then produces the function. Let us take some examples. Here I take 3x squared. I know we have taken this example throughout. So, if you take 3x squared to differentiate, first thing is that you multiply the coefficient by the power. 3 times 2 gives you 6, and then you reduce the power by 1, that is 2 minus 1 gives you 1, and your final product will be 6x, and that 6 is called a derivative or a gradient function. For the integration part, we take up 6x, and here we subtracted, but there we are adding. Remember, this power is 1. So, if I add 1 plus 1, I get 2. So, the new power will be 2. So, the coefficient which was 6 will now be divided by the new power which is 2, giving you 3, and finally we write the answer is 3x squared. Now, look at this plus c. Why are we writing a plus c there? Remember, short while ago I was trying to differentiate the function 3x squared plus or minus with numbers, and it produces the same function. So, if you integrate the 6x, you are supposed to get the same function. So, which constant among them? We don't know. So, that is why we have to write a c. It is a value of c. We write the letter c is reserved for this kind of expression. We usually write c. Other constants like k, p and q we write if you have other types of question, but we write plus c there in A-level integration. So, let us go through examples. Here we have a function with a dy by dx equal x to the power 4. So, how do we integrate this function? How do we get the y function from this derivative function? If we go through the process, first thing is that increase the power by 1 and then divide the new power by the coefficient. So, which is the coefficient here is 1. If you increase the power this 4 to 5, it will be 1 divided by 5, and then write the expression as x to the power 5 divided by 5, giving you this one. And remember not to forget to write the c value there. You have to write the c value. It is a common mistake that students do not write c. If you do not write plus c there, you are going to lose marks in integration questions. It is very important. So, do not forget to write c there, just write plus c. Another example, here we have dy by dx equal x to the power minus 5. So, what is the process? Increase the power by 1 and divide the new power from the coefficient. So, the coefficient again here is 1. So, if you increase minus 5, you know it will be minus 4. If you increase minus 5 by 1, it will become minus 4. So, the new power is minus 4, and then you get 1 divided by minus 4. 1 because we have coefficient 1. We never write 1 as a coefficient. So, that is why we are not writing 1. So, we have the new power is minus 4 divided by the new power is minus 4, and again do not forget to write c, add c there, you have the original function. Another example, we have dy by dx equal to x cube. Here the coefficient is 2, the power is 3, so you know you have to increase the power by 1 and divide by the new power. You are going to get 4 here, because if you increase 3, you will get 4, and 2 was already there. So, 2 divided by 4 will be half, and writing the answer is x to the power 4 divided by 2 plus c, half. That 1 again we usually do not write that. Another example, dy by dx equal 3x to the power half. So, apply the process of integration. We have to increase this power by 1. You know, if you increase half by 1, you will get 3 halves, which is 3 by 2, and then dividing that whole fraction, that whole power from the coefficient, you will get 3 divided by 3 by 2. If you clean this fraction up, you will get 2. Why? Because you know the reciprocal of 3 halves will be 2 by 3, which 2 goes and multiply to this 3 here, getting 6. 6 divided by 3 will be 2. And then x to the power 3 by 2, again we are writing that plus c there. It is very important to write that plus c there. Now, integration comes with a notation. So, question is, what is the notation we use for integration? The symbol that we use for integration is this elongated S kind of symbol. This symbol has a history. So, I want everybody to read about the evolution of this sign In the past, in different centuries, the symbol of integration has taken different forms, and in the modern mathematics we use this elongated kind of S kind of symbol for integration. What does this expression tells you? The whole expression you see is now called an indefinite integration. In your P2 mathematics, you are going to learn definite integrations. So the difference is that here we don't have limits of integration. So when we don't have limits of integration, we call it indefinite integration. So here, what are the parts of this integration? First, we have the integral symbol or integral sign. The meaning of that sign is to integrate whatever inside that symbol, or whatever to the right side of this symbol, you have to integrate. So that sign is the integral sign, and this expression here is the one to be integrated. Usually it will be bracketed if you have a complicated function, and that dx tells you the variable of integration. If dx is there, it means x is the variable. If dt is there, then that means t is the variable. So dx tells you the variable of integration, and the answer we get after differentiating the whole thing in mathematics we call an antiderivative. An antiderivative will be that function there, and that part also has a plus c, which we call the constant of integration. And as I have told you before, this whole expression here is called an indefinite integral. So usually integration question comes with this symbol. So without saying integrate the following function, they will usually write this symbol. It really means integrate the function inside that symbol. So let's go through examples. Here we have an expression to be integrated. You can see the integral symbol tells you integrate the function with respect to x. This is what it says. First, note that this function has two terms in it. So question is, how do you integrate functions with more than one term? Very simple. Same thing as differentiation, you integrate term by term. So first thing is, as we have seen before, increase the power by 1, which will be half plus 1 will be 3 by 2, divide by the new power, that is it. And then in here also increase the power by 1, it becomes 4, divide by the new power, and finally you do not forget to write plus c. You should have written plus c in this step here. For explanation purpose, I waited for the last step. The step in which you do the integration, you must include plus c, and it has to carry forward. If you have more other steps, you have to write c in every other step. So here when I say deal with the fraction means just write this one in a neater way, like 1 divided by 3 by 2 is better, is no better than writing 2 by 3, because this is a cleaner function, cleaner fraction. Even here 2 by 4 you reduce it to write as half. Another example, here we have x to the power minus 3 by 2 plus 2. So as before, integrate each term separately. First term x to the power half divided by minus half, and then that 2 there. Integration of 2. I have seen in the past students have difficulties in finding out the integration of a constant, but it is not difficult if you think like this way. Think like this way. When you differentiated 2x, what did you get? You will get 2. So if you reverse it, if you integrate 2, you should get 2x. That's very easy. So if you integrate a constant, you get the constant times x. That's it. So if you integrate 2, you will get 2x. If you think another way, when 2 is there, there is a hidden x to the power 0 there. Nobody writes x to the power 0. X to the power 0 next to it is actually 1 in algebra. X to the power 0 is 1. So that x to the power 0 has a power of 0. But if you increase the power by 1, 0 plus 1 is 1. So now that x appears. So that is why we have a 2x here. So what if you integrate, what do you get if you integrate 3? You will get 3x. What if you integrate minus 300? You will get minus 300x. So that's how it goes. And then, as I told you before, clean this fraction and you are getting minus 2 x to the power minus half, and then plus 2 x, and then last one will be plus c. Sometimes the function you get may not be very easy. I have so far shown you very easy functions. Sometimes the function you get may not be even ready for integration. So you have to be really careful about making the function ready. So a function may not be ready for integration if it has the following features in that function. First of all, if the function has any variable term inside a root, be very careful, not a numerical number inside a root. It's not an issue. But if a variable term is inside a root, you have to fix it by applying the law of indices. For example, these expressions needs to be fixed. And if the function has any variable in the denominator, then also it's a problem. You have to fix it. And if the function has variable terms bracketed together, you have to expand the brackets. So in order to make the function ready, first thing there, apply the laws of indices. Second one here, again apply the laws of indices. You know, we have seen one law where we can make this x appear on top by applying the laws of indices. And if you have brackets like this, expand the brackets the normal way you do in algebra. So there we have an example. So look at this function. This function is not ready by many reasons. First, this 2x whole thing squared needs to be fixed, that squared to be applied, and that root x needs to be fixed, that x squared which is in the denominator needs to be fixed. So we have three fixations. First, 2x squared, the 2x whole thing squared should be fixed. So what does it say? Integrate whatever expression inside with respect to x. So we ask the question, is the function ready for integration? The answer is not ready, because we have many problems, like here we have a bracket to be expanded, here we have a variable inside a root, here we have an x squared which is in the denominator. If you fix all of these, you are going to get the following. For example, 2x the whole thing squared, if you fix it, you will get 4x squared. In here what we do is we split this numerator because we have a common denominator. So you write root x over x squared plus 5 over x squared, and remember we haven't done integration, so do not remove this sign. We have only done algebra. So if you continue doing this by applying the rules of indices, we get the following, and now you can see each term is ready and we are going to start integration. See, each term is now in power form. We are ready, we can start integration. So do the integration term by term and get the answer is this one. Very important, integration of each term must be done in the same step. You cannot do one term integration in second step and then the other one in the third step, which is not good. You cannot do that in integration. The rest of this topic will be done in our next teleclass. Thank you very much.